Today what we're going to talk about is vocabulary of polynomials and adding and subtracting polynomials. So just so you know, everything that we've dealt with so far actually has a name. So if we identify based on the degree means the highest exponent in a polynomial expression. So if I were to give you this expression 3x plus 2, this has an exponent of 1. Therefore, that's the highest exponent, and we would call that linear. Everything we did last chapter was quadratic. Quadratic has the highest exponent of 2. So if you look at the highest exponent is 2. Therefore, this would be named quadratic. If I were to give you this expression here, 3x minus 5, our highest exponent is 3. We would call this one cubic. And then if I were to give you this expression here, 2x to the 4th plus 7x squared plus 4x, we have 3 exponents. We have a 4, a 2, and a 1. But the highest one here is 4, therefore this is called quartic. And the last one is 5. If I give you negative x to the 5th plus x squared, our highest exponent is 5, therefore this is called quintic. Not only are these polynomials named by the degree, the exponent, they're also named by the number of terms. So if you have one term, it would mean that you just have one number or one variable or one thing not separated by an addition or subtraction symbol. So we have a monomial. Mono is the word for one. Mono is 1, so there's just one term here, which is 25. If we have a binomial, bi means 2. Think about riding a bicycle. Okay, so that would mean we have 2 terms. We have one term here in x, one term here in 2. And notice how they're separated by an addition or subtraction symbol. A trinomial, tri meaning 3, has 3 terms. We have x squared plus, let's say 3x plus 2. We have term 1, term 2, and term 3, again separated by an addition or subtraction symbol. And if you have 4 or more, it's called a polynomial. Poly represents the word many. So let's say we have 11x to the 4th minus 14x to the 3rd minus 5x plus 13. So we have term 1, 2, 3, and 4, again being separated by those addition and subtraction symbols. So what we're going to do is we are going to identify each of these expressions based on the degree and the term. So if you look in this first example, 5x to the 4th minus 3x squared plus 12x, what is the highest exponent? I hope you notice that it is 4. So if this is 4, we would identify this as quartic, because that's what we said degree for 4 is quartic. And you can always look back up at the top of your page. And how many terms do we have here? We have 1, 2, 3. So we would call this a quartic trinomial. What's the highest exponent in the second expression? It's 2. So we would call that a quadratic. And how many terms? You have 1, 2. So this is called a quadratic binomial. The highest exponent in the third is 1, so we would call this linear. And there's only one term, so this is a monomial. In the next one, the highest degree is 4, so again this is called quartic. And there's 1, 2 terms, so again this is binomial. So a quartic binomial. In this one we have a degree of 5, so if you remember that's called quintic. Quintic, and we have 1, 2, 3, 4 terms, so 4 and above is called a polynomial. If you see that your degree is 0, there's no variable, there's no exponent, it's 0. This is called constant, which means it's not going to change. This number will always be 24. It's called constant. So a constant with one term, a constant monomial. That's the vocabulary. Now what we're going to do is we're going to add and subtract these numbers. So it says when you add or subtract polynomials, only like terms can be combined. A like term means the same variable to the same power. When combining like terms, the coefficients are added or subtracted, but the variables stay to the same power. So the only thing that's changing when you're adding and subtracting is the number in front. The little number stays the same, it never changes. So the nice thing is when we add, nothing changes. Okay, all we have to do is put together our like terms. So let's always start with our biggest exponent, and in this case the biggest exponent is 3. Do you see any other x to the third powers? Oh, there's one, and that's it. So all we're going to do is we're going to add together the front. 5 plus 3 is 8. And then again, the x to the third power stays the same. So if we go one down, we have x squared. And remember, always take that symbol out. It is so important, so do not forget it. So do we have any other x squareds that are not highlighted? So there's one. So again, we're only going to add the numbers. 3 plus negative 5 is, again, negative 8x squared. And lastly, let's have those constant numbers, the numbers that just stand alone. And 9 plus 12 is 21. There is a difference when you are subtracting. With adding, you just go ahead and add. When you are subtracting, you must distribute the negative to everything in the parentheses that follow. So all I'm going to do first is I'm going to rewrite this first trinomial, the first set of parentheses, 10z squared plus 5z plus 19. And I'm going to distribute my negative. So negative 1 times 3z squared is negative 3z squared. Negative 1 times negative 6z is positive 6z. And negative 1 times 2 is negative 2. So basically all we did is changed the symbol in the parentheses that follow. So again, let's start with the highest exponent. In this case it's z squared. So let's go through and look for any other z squares, remembering to take the sign in front. So we have 10z squared minus 3z squared, which gives us 7z squared. Okay, then we're going to go down to z to the first power, which is just kind of z hanging out there. So we have 5z plus 6z, which is 11z. And then again, our constant numbers, 19 minus 2, which gives us 17. For problem 3, we are adding, but we're adding this 2 times a set of parentheses. And remember, we always have to see if we can simplify first. So we are going to have to distribute that 2 to the parentheses that follow it. So again, I'm just going to copy down that first set of parentheses. And now let's distribute. 2 times 3w squared, again, you just multiply the front numbers in front. That's going to give us plus 6w squared. 2 times negative 9w is 18w. And 2 times 23 is 46. So let's start with our highest exponent. Our highest exponent is 4. Any other 4s? I don't see any. So we're going to go 2w to the 4th. So if there's nothing to combine with it, just bring it down. And again, we have to go in biggest exponent to smallest. So our second one is w squared. We've got another right here. So 7 plus 6 is 13w squared. We do have a w. So we say minus 18w. And then last but not least, our constant numbers. So negative 11 and 46, which gives us positive 35. And since you cannot combine any more like terms, that's your answer. So let's try this again. We are going to be distributing a negative 4 into the parentheses that follow. So bring down your first set of parentheses. And then go ahead and distribute the 4 to everything in the parentheses that follow it. So negative 4 times 6x to the 3rd. So remember, you just multiply those numbers. That'll give you negative 24x to the 3rd. And then if we distribute negative 4 to 5x squared, negative 4 times 5 is negative 20. Sorry, not w, x squared. And lastly, negative 4 times 12x is negative 48x. So we start with the highest exponent. Again, this is 4. I don't see any other 4s, so let's just bring that one down, 11x to the 4th. We have x to the 3rd power. So 2x to the 3rd minus 24x to the 3rd is a negative 22x to the 3rd. And then we have x squared. So nothing else to combine with that, so we're just going to go ahead and bring it down. And then we have negative 10x and negative 48x. So we would say negative 58x. We're going to do one more type of problem with this, and it's a perimeter problem. And it says perimeter means the distance around a figure. To find the perimeter, you have to add the sides of the figure. So we have this side here and this side here. So we have one length, one width. So if I were to just add these together, 2x squared plus 10x plus 4x minus 3. Does that give me the whole perimeter? So we have here and we have here. Did that cover the whole perimeter? And I hope you're thinking, no, you're crazy. So this side, because it's a rectangle, is the same. So it's the same distance. And so that would mean that this is 4x minus 3. So we have to add all of the sides. Okay, so now we have covered the rest of the shape. So we're going to add up all of those sides. So let's start with our highest exponent, which is 2x squared. And we have 2x squared plus 2x squared, which gives us 4x squared. And then let's look at all of our x's. We have 10x plus 4x plus 10x plus 4x, so 10, 14, 24, 28. So we have 28x. And then lastly, just those constant numbers, negative 3 and negative 3, which gives us negative 6. All right, if you have any questions, go ahead and ask your teacher. Otherwise, move on to your in-class practice.